In this presentation, we're going to extend the concept of a pickup to contribute to a basic point system. And this core concept is something that will apply to, in this case, we'll apply it to points, but we could also use this as a simple health system. So in the first example that we'll cover, we'll pick up coins and contribute to a point value. And then in the next example, we'll pick up things that will either contribute or subtract from a health value. And then we can use those values to determine whether we're alive and able to play the game, or whether we've lost all our health and have to restart. So in our last presentation, I placed a coin inside the scene and I modified it a little bit. On the idle state, I have it rotating, and then we have our trigger event from the previous presentation. And this is just a simple on-trigger enter when we collide with an object that's tagged with player. So when our player character, our first-person controller, crosses the threshold of the collider, we fire off the pickup event. The pickup event is wired off to state 1. Now, state 1 I haven't renamed yet, but when I go to state 1, its current action is to destroy itself. Now, when I test this, I'll walk through the coin, and when I cross its collider, it destroys itself. Now, we need to be careful about this, especially when we start having this state contribute to a point system, because we don't want to destroy the object before it gets a chance to contribute to points. More about that in just a few minutes. Now, we're going to revisit this state here in a short bit, but I want to spend a little bit of time talking about variables. Variables inside Unity is where a lot of, or inside programming really, any kind of programming, but specifically inside Unity, we're going to gain a lot of flexibility. Rather than having fixed points of data, we can have variable data that depends on the user input, or depends on the progress of the player. We can start to track data in our game, and this is where things start to become very interesting. Now, in order to set this up, I'm going to start with an empty game object, and the empty game object is going to be a simple container where we're going to add some simple logic. Okay, so I'm going to get started by going to Game Objects, Create Empty. Now, an empty game object, as we've discussed in the past, is just, it's a game object that only has a transform component. Similar to another object, if I introduce a cube, this cube object, it's called cube, but it has a transform, and in addition to the transform, it has a cube mesh, a box collider, a mesh render, and a default material component. Now, if we were to pull off all of these components, I could just get rid of these and choose to remove component. If I were to strip this cube down to its essentials, essentially I have an empty game object. This, which once was a cube, I've pulled away all of its components, leaving only the transform component. It's essentially an empty game object. I'm going to delete the cube object for a moment and go back to my empty game object. So the empty game object has a transform, but in this case we're not so concerned about what its location is, but just that we have an object in our hierarchy that we can attach some logic to. I'm going to rename this game object. I'm going to call this Player Manager. Now, this is a fairly important concept when it comes to game design. The Player Manager is going to be this thing that exists independent of our player. Okay, so right now I have this first-person controller, and I'm considering that my player. And I have a separate object called Player Manager, and this is going to contain the logic that might include things like our current health, our score, maybe what level we're on, any kind of save data. This is going to be an object that we don't destroy. We may want to destroy the first-person controller, or change the logic of it, or maybe we get into a position where we want to enter a vehicle, and rather than having a first-person controller, we swap that out to a third-person controller. There may be some instances where we don't want to use this character controller for the time being. Well, by having a separate game object that maintains persistent data and keeps track of all the relevant information in your game, you can reference a separate object. So I have this Player Manager object, and to demonstrate this point, the first thing that I'm going to do is I'm going to introduce a very simple state machine on this object. I'm going to right click and choose to add state machine. Now at this point we want to get in the habit of a couple of different things. We want to get in the habit of naming our state machines and our states. Now we can name our state machines by going to the FSM tab, and you can see that my state machine is currently called FSM. I'm going to keep the FSM extension on the front end, and I'm going to call this Player Manager. I'm just going to use the same name as the object for now, and we'll put a finer point on that a little bit later in this class. And now I'm going to go to the state. Now the state 1, I'm going to just use an idle state like I do in most of my other state machines. I can rename this state with a more compelling name. If I layer in some logic and it starts to do some different things, I can change the name of the state later. But for now, as a starting point, I'm always going to name it idle. That'll get me in the habit of renaming these states, even if I don't have a really compelling name for it for now. Now, the first example that I'm going to demonstrate is I'm going to print a little bit of information on screen. Now, the first method that we're going to use to print some information on screen is not the most efficient, and I'll show you another method later. But for now, we want to get just a little bit of data up on screen so that we can track information about our player. And so the first thing that we're going to do, I'm going to go to my Actions tab, and I'm looking for a GUI. And inside the GUI category, there is a GUI label. And the GUI label is a really simple way to get some information up on screen. So I'm going to add the GUI label to this state that's inside my Player Manager. And you can see that the GUI label, there's a couple of different fields here, and we're going to skip some of these. There's an image field. We're going to ignore that for now. But there's a text field. And in the text field, this is where we can type in a little bit of information. Now, inside the text field, I'm just for now going to type in hello, ! And we'll notice that we're using what's called a normalized screen. All the way down here at the bottom, it says normalized and it's checked, and we're going to let that stay checked. And there's a width and a height value of 1, and there's a left and a top field that's set to 0. Now, when I hit the play button, somewhere in this screen, if we look around, if I look in the top left-hand corner, I'll look up in the sky, you can see it a little bit more clearly. Way in the top left-hand corner, it says hello. I'll toggle the play button, and I'll go back to idle. So it's printing this. In the relationship of the left side of the screen, there's this value of 0. And from the top of the screen, there's this value of 0. And what this is saying is that we're looking at a normalized screen. So the width and the height of this are 1. So the value from the left side to the right side is from 0 to 1. So if we were to set the left value at 0.5 and we set the top value at 0.5, we're basically saying half of the screen over from the left side and half of the screen over from the top down. If I hit the play button, we should see hello popping up in the middle of the screen. I'll toggle the play button, and I'll go back to my idle state. Now, I actually don't want my data directly in the center of the screen. I do kind of want it anchored off to the top left-hand corner. And so what I'll do is I'll just do 0.1, both from the left and the top, and I'll hit play and see how that looks. And that's okay for now. Really what I'm looking to do is I'm looking to get some data on screen that I can track and start to publish information about the game to the screen. And so this GUI label is doing exactly what I want it to do. Now, when it comes to data inside Unity, specifically Unity, but all kinds of programming, we can use this concept of variables. We're just going to jump right into it. I'll post a little bit of reading about variables that'll kind of rough out some of these concepts. But the core concept of a variable is that in this text field, right now we're printing hard data. So this is kind of hard-coded information. It says whatever we type in here. But if we want this to reference a variable object that could contain anything, we don't want to type in information here. We want to use a variable container. And the way that we create variables is we go to the variable tab, and from the variable tab, we can create a new variable. Now, there's several different kinds of variable types, okay? I'll post an article and a video after this video in the lesson folder to put a finer point on variables. But for now, we can create a new variable, and this is going to be attached to a given state machine. So I'm inside the player manager, I'm inside my player manager state machine, and I'm going to the variables tab and I'm creating a new variable. Now there's different kinds, different types of variables. The different data types are listed here. Now, when we make variables, they have to be of compatible variable types depending on what we're trying to do with them. Now, for the sake of this class, we're going to focus on just a couple of kinds of variables. We're going to focus on float variables. We'll talk about game object variables, and we'll talk about string variables. We'll also touch on int and bools, but these are just different kinds of data. Now, a float and an int, these are very similar kinds of data. These are number data. The difference between an int or an integer and a float or a floating point number is that an integer is a whole number, where a float can include a decimal. So we can have a number like 1.5, whereas an int, you can have 1, 2, -4, that sort of thing. Floats are very, very common. In fact, when we look up in the inspector panel, if we look at the transform, our position, rotation, and scale data are all made up of floats. We can see that because if I look here in transform under position, the x position of this game object, the x position is 585.572. That's a float value, okay? So when we're talking about different data types, we have to use valid data types for different functions. Now, if we want to print some information to screen, we may want to use a float to track different kinds of data, but in order to print it to screen, we need to be able to print a data type that's eligible to print. And in the case of printing to screen, we need to print a string type variable. Now, again, I'll put a finer point on these data types a little bit later, but just to demonstrate this, I'm going to create a string type, a string variable type. The new variable name that I'm going to call this is, I'm just going to call it print to screen. Now, one thing about naming variables, this is very important, is that you never want to start off with a capital letter. It's very important that they're always lowercase. We can use capital letters later in the naming convention, but we never want to start with a capital letter. We also don't want to use numbers. We only want to use the alphabet when it comes to creating variable names. So always start with lowercase, always use letters only, with the exception of characters like underscore. If you want to use an underscore, you can. You'll notice that I'm not using space in here to distinguish between the name of this variable. So we want to avoid spaces, start with lowercase, and we want to stick mostly to letters. Now, I'm using this Camelback naming convention, which is using capital letters to distinguish between different words in the variable. I don't need to give this variable such a long name, but I like to overname my variables, at least at this point in this semester, when I need to track information a little bit more clearly. So I have a variable called print to screen, and I'm going to add that. So I now have a variable. It's titled print to screen. It's not being used. That's why it's saying 0 uses. And the data type is listed here. Now we can change this data type after we create it. If we create a variable with the wrong name, or the wrong data type, we can change it, but we have to use the proper data type when it comes to certain actions or programming. More about that in just a few minutes. So at this point, I've created a string variable. I'm going to go back to my state. Now, the string variable contains information, and currently, if I go back to variables, if I select our print to screen variable, this string data contains no information, and I can see that because if I look in the string field, it's completely blank. We can ignore all this other information, but we have our variable name and then we have the data that it's holding. And in the string field, I'm going to type in something, and this does not need to follow any kind of naming convention. This is the actual data that it's holding. I'm going to just write a short little sentence. This is the text that is printing to screen. And I'll hit return. Now, this print to screen variable contains this text by default. If I go back to my state, rather than typing in this information here and saying hello, if I hit the play button, just to remind myself what is being printed here, I see it says hello. I'm going to go back to my idle state, and inside this GUI label, I'm going to change this text. Rather than printing, hard coding the information in here, what I'm going to do is over on the right side, you'll notice there's all these little buttons that look like they have little line spacing here. This is a little toggle button, and anytime we see this button, this gives us the opportunity to switch from hard-coded data in a field to, if I click on this button, it switches to a drop-down menu. The drop-down menu contains valid data types for variables that we've created. In other words, this text field, and if I roll my mouse over the text field, if I let the pop-up happen, you'll see that the parameter underneath my mouse is saying that the parameter that's required in this field is string data. String data happens to be alphanumeric information. This is information that is intended to be read. It could be things like our name, the color of the shoes that we're wearing. This is just narrative information that we can read. Other variable types, including things like a float or these float numbers, this is information that is intended for things that we might want to do math to. Okay, so we can do math to floats and int variable types, but if we're going to use a string data type, we can't really apply math to a string data type. Okay, so there's different kinds of types of data used for different things. And for now, what I want to do is I want to toggle this hard code field, and I want to click on this drop-down menu and choose print to screen. Now, the print to screen, instead of printing hello exclamation point, it's going to print whatever data is contained inside this print to screen. So when I hit the play button, you can see that it's printing the data that it contains. It's not printing the actual title of the variable, but whatever data is in there. So if I go over to my variable and I click on my variable and I change this, and I'll just shorten this up to this is text, and I'll hit the play button, it's printing whatever that variable type contains. Now, you might be scratching your head and say, well, that seems a little redundant. Why would I want to do that? Well, now that we have a variable, we can feed information into this variable to have it contain whatever we want it to contain. Okay, and by feeding information into that variable, we can present dynamic information on screen. So, for example, I want the ability to collect points. Every time I come across a coin, I want to collect it and contribute to a point value. Okay. So the first thing I'm going to do in order to do this is I'm going to create a variable that's going to track the number of points that I have. Okay, so I'm clicking on the variable tab. You'll see that I can't add a variable right now. It's because I have an existing variable selected. If I just click and deselect that, I can choose new variable type, and I'm simply going to call this points. And the variable type, I'm going to leave this as a float variable, and I'm going to hit add. And so now I have two variables that are attached to this state machine. I have points, which is a float type, and I have print to screen, which is a string type. Now the points float variable, it's a float type, which means that this float value by default you can see is set to 0. And that's what we want. We can leave it set to 0, but we can also change this. If we wanted it to start at, say, 0.2, we could set that, or we could say start at 1, a whole number. So a float can be a floating point number, a decimal point, or it can be a whole number. But I'm just going to zero out this value. So currently our points are equal to 0. Now if I go back to my state, you'll notice that if I try to print the value of points to screen, I can't do it. It's because it's the wrong data type. this text field is requiring a string type data in order to print to screen. So we have different data types to perform different functions. Now there's only a couple of data types that we're going to use in this class, so don't let this discourage you. And we'll put a finer point on all these data types a little bit later, but for now we just need to focus on the idea that we have string data that's being printed to screen, and we also have point data which is currently not being printed to screen, but we're going to fix that right now. In order to get the point value to print to screen, what we need to do is we need to convert our float value to string value, okay? And so what we can do is we can go up into our actions and we can type in convert. And once we type in convert, you can see there's a convert category, and inside convert, we can convert lots of different data types. What we want to do is we want to convert a float to a string. So I'll double click and add that. So I now have two actions. The first GUI label is printing a string to screen. The second action, we're going to convert our points float to a string. So the float variable that I want to use, if I click on the drop-down menu, you'll see that we have a points value. So I'll choose that. The string variable that we want to store our data into is the string variable that we created before. Now you'll notice that when I choose print to screen and I hit play, a couple things are going to happen. The first thing that's going to happen is that it prints 0 to screen. Okay, the default data for the string type variable is whatever we typed in here, but because on our state 1, our idle state, we're converting the value of points to a string variable, it's inheriting whatever the value of points is. Now I do want to point out it's really important that we check every frame, okay, because we want to constantly print the value of points to screen. If we don't check every frame, we could increase the value of points while we're playing our game and never see the result of it on screen. So we want to constantly do this conversion. Every frame we want to check to see if points is a different value. And for now, there won't be. I'll hit the play button and you can see that my value of 0 is just kind of floating there at 0. Now what we want to do is we want to, when we pick up something like a coin or even this cube, we want to contribute to our point value. Okay, and this is very simple to do. I'm going to select the coin. We've already got the logic set up for the pickup. Okay. Now, when we pick up, we're in the idle state. We cross the threshold of the collider for the coin in this case, and we go to state 1, and it destroys itself. What we want to do is, in addition to destroying itself, before it gets destroyed, we want to add to a float variable. Now, there's going to be a little bit of a glitch here. In order to add to a float variable, I want to go into math. There's a math category, and I want to do a float add. Okay. Now, if I forget that I'm looking for math and float add, I can just type in float, because that's the kind of variable that I want to influence, and I can see all these different options that I have for influencing that variable number. If I remember the name of it, I could just type in float add in the search field, or I could just manually look for it. Now, if I double click and do a float add, I want to make sure that the float add is occurring above the destroy self, because if destroy self happens, these actions run, they loop from the top down. There's a hierarchy to the way that these actions run. And if destroy self happens first, there's a very good chance, depending on the amount of logic that you have on this state, that the object is going to destroy itself before it gets a chance to run the existing logic that's underneath it. So the destroy self is really the last thing that we want to happen. So I'm going to move this float add action up. And the float add variable that I want to add to, if I click on the drop-down menu, you can see that I have no options here in my drop-down menu. And there's a very good reason for that. When we made our variables in our player manager, and I'll just go back to my player manager, and I'll go into the idle state and look at the variables. These variables are attached to this state machine that is attached to this game object. Okay, so only this state machine by default can talk to these variables. And that's for the sake of efficiency. We don't want to have to track variables in our entire game unless we specifically need them. There are a couple of different ways to get variables from one state machine to another. It's a slightly more advanced topic, and we'll talk about that a little bit later. So we're going to do something a little bit different here. I'm going to create what's called a global variable. The unique thing about global variables is that any state machine can access this information, and it can pass information back and forth between two different state machines. So here's how we're going to set this up. Now remember, if I go to my idle state, I just want to review this logic. The GUI label is printing the value of our print to screen string variable. And then we're converting a float to string down here, and we're using our local float, which we called points, to convert, and we're getting the result of that. But what I'm going to do is I'm going to go to variables, and rather than creating a local variable, I'm going to go down here at the bottom where there's a global variables button. I'm going to click on global variables. That's going to open up a new window. It's very similar. It's very similar to the standard variable window, but it's a standalone window, and this is kind of a unique environment. Any variable that we create at the global level, any state machine can talk to it. So I'm going to create a new variable, and for the sake of this demo, I'm going to call this global points. Now, normally I wouldn't call this global points, but this is just to demonstrate this concept, and I'll hit the add button. Playmaker tells us that we're adding a global variable. That's okay, we'll say yes. And now you can see that this window functions exactly like the local variables. I just lost it, so I'm going to click on global variables again. The unique thing about this is that global variables exist independent of each state machine. For example, right now I have the player manager state machine that I've created, and I can see these local variables. If I go to my coin object and I go to the variables tab, you can see that there are no variables here. That's because the variables that we're looking at are attached to whatever state machine we're looking at. Now, because we've created a new global variable, what we can do is we can go back into our state one. This is the place where we did a float add. Now when we click on this drop-down menu, you can see that we get a submenu. If we had any local variables on this state machine, for example, if I make a test variable, if I go into this state, if I click on this drop-down menu, I could choose my local test variable, which is not what I want to do, or I could choose a global variable. In this case, we have global points. And so what I'm saying is we're going to add a value to global points. Global points is currently set to 0. I made a mental note of that. And then we'll add a value of 1. We're going to leave these unchecked because we don't want to do it every second. We don't want to do it every frame. So the logic here is that the coin is sitting here and it's spinning, it's rotating, and it's waiting for the player to come along and pick it up. When that happens, it transitions to state 1. When state 1 runs, we're going to do a float add. So we're going to go find a variable. We're going to add 1 to it, and the variable that we're finding is a global points. We're going to add 1 point to it, and then we're going to destroy itself. Okay, now I have a little bit of a bug, a little bit of a glitch, and that is if I go back to my player manager, if you remember, what's my bug? You guessed it. The bug that I have is that my GUI label is printing a string value that's getting its data from a local points value. So if I hit the play button, I'm seeing 0. Okay, and if I walk across that coin, I was hoping to see that value of 0 go up to 1, but it doesn't. And the reason why is because in our player manager, we're printing the value of local points, or just the points, which, as I mentioned, our coin can't contribute to a local variable, or at least not in a very easy way. So what I want to do is I want to convert float to string. The float that we want to use is the global points. So now we're referring to the global variable that's called points, which is what our coin is referring to. So now when we hit the play button, we should see 0. Well, now it's 1. Okay. And then when I cross the value of coin, it goes up to 2. So somewhere it looked like my starting value of global points. Okay, it looks like it's remembering what the value of global points is, but it's moving up, so that's a good thing. We can fix that other bug. Okay, hit the play button. In order to get to global variables, there's a number of ways that I can get to it. I can go into the Playmaker window and kind of look around at these editors and go to global variables. Alternatively, I can just go into any state and go to variables and then find this global variables button down here. Generally, you're only going to create a handful of variables, global variables at least. So, you know, I normally don't keep this window open. We'll just make a couple of these and then reference them as needed. I'm going to start off by setting my float value to 0. I'll close this and hit the play button. And now you can see our value is 0. We pick up a coin, it is now set to 1. Now you'll notice that when I hit the play button, if I toggle the play button and I come back to it, because I'm setting the points value to 0 instead of nothing, it essentially resets that value each time we hit play. So, and we'll put a finer point on that a little bit later. I realize that was a lot of information when it comes to variables, but there are so many kind of little things that are connected to it that presentation went a little bit longer than our previous presentations, but I will review that process from the ground up. Make sure that you read and watch the videos that are attached after this video, and then I'll go back into a review and show how we can implement this and apply this to a broader scope of mechanics in our game. But we'll do that in the next presentation.